Back, everybody. So on the kind of fun side, the last video there was some, at least looking at, looks like there's some plaza and stuff. Turns out my whole system crashed after that. I am now back up and running. I guess video recording and all this simulation is not necessarily the best for running everything. Um, okay, so we'll get to the next step of this now. So now we want to just do, instead of a gate level modeling, building these with gates, we're just going to do it with taking the equation that you see here, and we're just going to assign it. So remember, this is kind of behavioral. You can really directly imply the gates from it, so it's a perfectly fine synthesis that's on here. It's a dubious distinction, in my opinion, but I do get what they're saying. You're not explicitly making gates, you're giving an equation that pretty much explicitly specifies a gate. But anyway, we'll do this next zero and the next state one here. That's what we're going to implement over here on the equation version. Oops, stop scrolling chunky. There we go. Okay, so this is the next section we're doing. So you'll see it's Model 1 equation. The inputs are the same. I have the same exact states. Um, you know, eh, eh, eh. Oh, that's weird. It keeps doing this to me. That might be why it's having some problems over here. This is supposed to be up there. I thought I had saved all that. Ha ha. Shows me. Oh, I'm evidently having some fun with my internet connection. That might be why the system crashed on me. So I had cut and paste a bunch of these, and for some reason it um evidently it some earlier version had that cut and paste, but I had saved it and then did the last video, and it when my system crashed hard, it evidently undid all of that. We um I'll try to get that fixed when my internet gets better, but I'm probably pretty hosed at the moment because of the recording process. Hopefully the sound and there's no gaps again. Anyway, to get back to it, um, these are basically taken from above. We're still doing the same assign output. This always loop with the if not reset and up, if I'm not doing a reset, then just, next state goes to state. If I am doing a reset, just give it zero. Um, but you'll notice here, I now do assign statements. This is the equation version. And this says next, assign next state bit zero to be S1, the caret. You're used to in C, that means exponentiation. However, in Verilog, caret means XOR. So this is S1 XOR the input. So whenever you see that little caret, which most people think of as exponentiation, to us it means exclusive OR. And then you'll see we have our um, three different AND gates, not in and S0, or um, S0 and S1, or not in and S1. And if you look at these, you'll see not in and S0, that's the first one, or or state 0, state 1, state 0, state 1, or not in and S1, not in and S1. So I just took the equation and just directly wrote into Verilog syntax, just like I also have next state 0 is equal to S1 exclusive for in, which is what you see here. So that's a very easy way to write it. You notice it's slightly simpler than doing the gates. Um, when it comes time to do the simulation, now we hope my internet is strong enough to do this. We have to tell it that the device under test is now, you can see it defaulted back to RTL. It says I'm logged in. Hopefully it'll let me save this change. Otherwise, I'm going to have to redo this. So Actually, I don't need to copy and paste that. I'll just type EQ over here. Save. Um, that means I might not be able to run this either. Yeah. So evidently after rebooting, I'm still having some issues. You can see the code. I'm gonna then, since I'm having some issues, I'll talk about the RTL code here, and then I'll do both of the simulations for EQ and RTL in a separate video once I get this running. Hopefully, it's still running well enough for the video to go. Okay. For the RTL code, so this is now register transfer level. We're really concerned. Register transfer level means from register to register. So we're not worried about even stating the equations or anything else. We're just very easily trying to do it. So it's easiest to handle that directly from this state table. You can also think of it as from the graph. I like to think of it as from the stable though. Um, and so if you kind of look at this state table, I'm going to try and make it so you can see the whole state table when I have the other window open. There we go. Um, so um, everything again, up above is the same except for, of course, the name. So that's a straight carry through. I've set up, as I mentioned in our class video thing, I've set up a parameter for each of my states, right? A is 0, 0, 2-bit 0, 0. B is 2 bits 0, 1. B is 0, 1. C is 1, 0. C is 2 bits of 1, 0. D is 2 bits of 1, 1. D, 1, 1. So these parameters basically allow me to use the names. So that I can just say always at case S, which is my state. So based on whatever my state is, if I'm in state A, right? If I'm in state A, um, and then I take a look at this. So I'm in state A if not in, i.e. if input is equal to 0, the next state is A. If input is 0, next state is A. Else it should be B. Else next state is B. If I'm in B and the input is 0, next state is C. B, input 0, C. Else, it's B. Else, next state is B. So C, right, input 0, I go to D, else A. If I'm in C and it's 0, I go to D, else A. A. If I'm in D and I get 0, I go to D, else I go to C. So looking back over here, D, right? Input is 0, I go to D, otherwise I go to C. So I literally can just take this chart, right? This is my case statement. Here's my if inside. So these are my cases. I've got a bunch of ifs, and I can just read down this chart and just put them right in, right? A, B, C, B, D, A, D, C. A, B, C, B, D, A, D, C. So this I can just directly pull from here, and then case is the outside logic, and the if is the inside. Really stupidly easy to implement this RTL, right? This is why this is so nice. I don't have to design an equation. I don't have to do anything. I can just directly take my state table, which I got right from my graph. Very easy to set up. Boom, I've got a functional piece of code that's going to work. Um, which, if my internet was working, would be lovely. Um, so I'm going to stop the video now. We believe that the code is working. I'm going to attempt to get my internet connection working so that we can run it and see what happens.